first one here wants you to write that as a single radical. So you can't have two different radical signs. You got to have to combine down to one root. Okay, anybody want to take a guess at what you think you do when you have a cube root of a fourth root? By a vote up here to times the 3 and 4, so you're saying make it the 12th root?
Yeah.
Okay, anybody else want to fight or argue for another idea?
No. Micah, go ahead.
Okay, so the general gut instinct is change it to a 12th root.
Yeah.
Okay, why do you think that would work? Why is that legal?
Because.
Because.
It's just magical at this world.
Okay, so you're right, but the why you're right, it really does just become a 12th root. But the reason you're right is that inside root could be a 1/4 power, because I have a 1 on the x, and the outside root could be a 1/3 power. And what do you do when you have a power to another power? You multiply it and you get a 1/12. But yes, the shortcut is just multiply the indexes together and you got it. That's it. You multiply the indexes. End of story. So you don't have to do all of this. Just take the 3 times the 4 and make it 12. That's that hard. So I could go hog wild crazy and do this.
Oh my goodness.
Okay? Tell me what that would be.
70, yeah, 75.
Yeah, the 70th root of 11. Just multiply them and you're done. Woo! So actually roots and roots and roots, not a big deal.
That's a really big root.
That is a really big root. Guess what? I don't think there's any number, any whole number times itself 70 times that makes 11.
You sure? Yeah,
Pretty sure on that one. Okay, well I guess we should talk about it though. What if you needed to work out, you actually wanted there is a decimal value that does that. There is an answer. There's a decimal that does that. If you want the decimal value, how do you find that? You do it on your calculator. The question is, where do you do it on your calculator? How do you get your calculator to do a whatever root you want? Press a button that's on there. Thanks so much. Above your caret, yes, above your caret key, control, it has a root with a little symbol. So literally, you can type, if we really want, this is going to be a terrible decimal, if we wanted the 70th root of 11, just whoa. So you want the 70th root of 11 and press enter, it's 1.034849, et cetera. But you can do any root you need to on your calculator. So you have a plain ordinary square root, and then this other one does any root you could ever want to do. So you know 150, you can do whatever root you want. Whatever number you can type in there, it will attempt to do. Now, if you exceed the memory because the decimals go out so far or something, then it might error on you because it can't handle the memory aspect of it, but it'll do it, it'll try. These calculators can go a long, long way on decimals, way longer than my old ones. These have a much bigger memory. Okay, last thing we're doing with the fraction exponents as far as simplifying them, we are going to solve some equations with them. So, you look at that, and some of you said that looks icky. Why? Too many fractions. Okay?
Oh, and it's a negative value.
But it's the same old thing. Yes, goodbye. Yes, you may leave. So you're looking at all those fractions.
Yep.
This thing looks horrible. It does. Okay, but it's like what you did over here on the other time. You thought it looked horrible when we had all these 3/4, 1/4, 1/3, 2/3. What did we do to solve the problem? We changed it all to common denominators. Do the same thing here. Just change it all to common denominators, and it's not nearly so bad. And I'm sorry, making common denominators is not the world's most difficult thing. So when you look at all those fractions, what's the common denominator for 2s, 3s, and 4s? 12. 12's worth a lot for things. So yeah, you're just going to change them all to 12. But here's the wrinkle. Do I have to do anything to that plain old ordinary 2 that's up front by itself with no power on it? Yeah. Am I not going to have to want to combine it with this 2 to the 1/3 over here? You have to realize that's 2 to the 1st. It also has to become 12. Every single thing up there has got to turn into 12. So, how many 12s would it be? You'd be so surprised at how many people have the most trouble with, it's a 1. How do I turn it into 12? It's 12 12. I see that messed up more than anything else. Okay, 2/3 is 8 12. 1/3 is 4 12. Then we'd have 3 12. And the bottom would be a negative how many 12? A negative 6 12. Okay. So now, this is the exponent problems you just did the other day. Exact same thing, it's just you have to add fractions. So, I'm multiplying the 2's, which means I'm adding the exponents. What's 12 12 plus 4 12? That is 16 12. We will reduce it later and simplify that. But for right now, just leave it. It's happy. Combine the ends. How many 12s will you have?
11 12.
You'll have 11 12s. And then on the bottom, we have a negative 6 12s. Okay, this is the up-down thing from the other day. What do I move? I have to get my ends combined. Do I move the bottom end up or the top end down? Why does the bottom one come up?
Negative.
It's negative. We want it to be positive. So yeah, we will take it out. We'll add, bring it up as a positive 6 12. Change the sign when you switch positions. Okay, so how many 12ths will that give us then on that end? That will give us 17 12. And then the 2's out front here, 16 12 would reduce. So at the end you should reduce it. 16 12 reduces to what? Let's not all jump on that at once. They're both divisible by 4, guys.
4/3.
Thank you, 4/3. That was a little scary. That's your answer. Okay. So if they give you just a whole bunch of fractions, don't freak. Just make them all have a common denominator and deal with it. Nope. These kinds will say simplify and leave it as a rational exponent. They will not tell you to put it back in a root. You could put it back in a root, but they won't tell you to. Okay? So, now we get solved. I could pause and save some time. Okay, we'll pause. This one's only got, this has got minor pizzazz. Okay, you'll notice the problem on the left has a fraction exponent. Fraction exponent is the same thing as a root. That fraction is a root. The one on the right, this has the root in it. So actually how you solve these is exactly the same way. Okay, so if it's got a fraction, I would leave it as a fraction. If it's got a root, leave it as a root. Okay, this is just normal solve for x. Nothing fancy here. How do I get x by itself? I would subtract 7, yep. So this is not anything fancy or new. Okay, then what would you do? You would get rid of the 2. Same thing you always do. And so you would have x to the 2/3 equals 9. Okay, now here's where life goes a little different. How do you get rid of a 2/3 power? Well, if it was x squared equals 25, how would we solve it? You would square root both sides. But let me point out, isn't that square root the same thing as taking it to a 1/2 power? Now that we know that, square roots are 1/2 powers, and it makes the powers cancel. So if you're looking at something like this, 2/3. Yes, Colby, woo! You hear what he said? No. If you got a 2/3 power, what gets rid of 2/3? multiplying it by 3/2 because it'll cancel when you multiply. But if I take the left side to 3/2, I take the right side to the 3/2 power. So then this cancels, 3's cancel, 2's cancel, and I'm left with x equals 9 to the 3/2. But we just learned at the beginning of this how to figure out what is 9 to the 3/2 power. How do you figure out what 9 to the 3/2 power is? You now put it back in a root. Is it a square root or a cube root? It's a square root of 9 cubed. And so the square root of 9 would be 3, and 3 cubed would be 27. Answer. Woohoo! So anytime you're presented with, you're solving and you have to get rid of the 2/3, I probably shouldn't have put those lines on there because you can't see what happened. If you have to get rid of it, just do the reciprocal of the fraction. So if you had x, whoops, let's try that. If you had x to the, something bizarre, 81 over 29 power, that would be horrible. How would you get rid of it? You take it to the 29 over 81. That's just how it works. That's all you have to do to get rid of it. So I'm not going to give you a whole lot of those. We don't see tons of those, but we see it occasionally if you have to solve with that. Okay, the things we see far more of are this dude right here. This baby happens a lot. Goodbye. And this last part will be very common sense to you. How do I solve for y? It's in a root. Get the root by itself. Okay, so you would add the 15 over. Yeah. Whoops, I changed color. So solve the same way. Get the root by itself. Add the 15 over. Then how do you want the root by itself? How do you get rid of 5? If times by 5, you divide by 5. Equals 3. Okay, now here's the wrinkle. How do I get rid of a square root? You square both sides. Yeah. So if I square both sides, I would get 2y minus 1, because the square root will go away when I square the square root, equals 9. Okay, is that hard to solve? No, this isn't bad. 2y equals 10. Y equals 5. We should have a lot of these. Okay, now, there's one little wrinkle. Occasionally, you will have answers here that do not check. Because when you square both sides, you take both sides to an even power, squaring makes everything positive. So if part of some of this represented negative numbers, you're going to make them all become positive. So sometimes when you take both sides to an even power, if you square both sides, your answer will not check. So if you've taken both sides to an even power, you will have to check your answer and honest and goodness really check your answer. Which means you have to put it back in the original problem to see if it works. But I don't expect a ton of work when you check. I always want to see a really basic check. You can do a lot of this in your head. If you stick 5 in for y, what will the inside of this be? 10y minus 1. That'd be nice. You'd have 5 times the square root of 9 minus 15 is supposed to equal 0. What's the square root of 9? So that would be, does 15 minus 15 equal 0? Yeah, that's good enough check for me. You don't have to show me lots of steps on the check. I'm not one who loves to check myself, so I don't expect 10 tenths of work. Just show me that you thought about checking.
How do you fix it if it doesn't check?
If it doesn't check, you say cross out the answer, it's no solution.
Okay. Oh, really?
If it doesn't work, it's a no solution.
I like that.
It's a done deal. It is not possible. Okay. Last problem.
This is mine.
Mm-hmm.
It costs that much.
Thank you.